Hello, we are now going to go over problem 1 from volume and surface area, benchmark G.7.5. Let's read the problem. Below is a triangular prism. Note the figure. What is the surface area in square inches? That's part A, and part B is what is the volume in cubic inches. Even though the figure is already drawn on the paper, you will be taking a computer-based test, so you need to get adept at drawing the figure as I have here. I'm going to show you here how to draw the figure. We're starting with the right triangle because our triangular prism has a right triangle as one of its bases, as its bases. Note, however, that all triangular prisms do not have triangles that are right angles. So we started with the right triangle. Next, we're going to go ahead and draw this rectangle that's extended off of the side. I do not promise that this will be beautiful, but it will be usable. There you have it. Next, we're going to go ahead and draw the dotted lines inside. And there you have it. I'm going to label the lengths and the types of dimensions if it applies, or if I can at this point. And here I see I have my 12, my 10, my 20, my 16 centimeters. It is very important to pay attention to dimensions when you're doing these types of problems, because at times they give you your information or your measurements in dimensions that are different from the measurements that they require, or dimensions that they require, I should say, in the answer. So pay attention to your dimensions, the measurements, make sure that they are consistent, because you may have to do a conversion. Okay, moving on to the next step. I'm going to go ahead and check the reference sheet for this figure's formula. If I'm finding, and I'm going to determine whether or not I'm finding the volume or the surface area. So taking a look at the problem says, what is the surface area? So that is the formula that I'm going to look for or reference on the reference sheet. Now taking a look at the reference sheet, I see that I don't have my figure here. Now, I could use something that is here, but it is going to be more beneficial for you to understand, being consistent with the definition, that the surface area is the sum of the areas of the faces of the figure. So I'm going to, after determining that I'm finding the surface area, I'm going to find, because it's not there on the reference sheet, I'm going to label, ID and label the faces of the 3D figure. So let me go ahead and take a look at that now. Here I note that I have two triangles and that they are congruent. 16 here, 16 here, that's the height for both of them, and the base is 12, and then we see in this case the hypotenuse in both is 20. So I have two right triangles. Okay, next, note that I am IDing and labeling the faces of this 3D figure because this figure was not on the reference sheet. I'm going to add this to this rectangle that we see here. So I have one rectangle here. Some of you might be asking, well, why don't you put a 3 next to that rectangle since you have 1, 2, 3 rectangles? There's a reason for that. And let me go ahead and go back to this triangle and put the dimensions on. For the base, it's 12 centimeters. Here it's 16 centimeters. And the hypotenuse is 20 centimeters. So as you write these, label them. For this rectangle, I'm going to have a 10 for the base, and for the height, even though it's laying down there, good afternoon, Pioneer. 10 centimeters will represent the base. For the height, even though it's laying down here, you can see the height of this rectangle is 20 centimeters. And clearly I have not drawn this to scale. Okay, so next I'm going to take a look at this bottom rectangle, which has a base of 10 and a height of 12, or you could see it the other way as well. Okay, so let me go ahead and draw that in and label it. Let's see here. The last rectangle is in the back here, and we see we have a height of 16. It's clear to see that the base here, parallel to this side, is 10 centimeters. Okay, I'm now going to verify two triangles with a base and height of 16 and 12. I have one rectangle with a base and height of 10 and 20. That's this one. And then I have a bottom rectangle with a base and height of 10 and 12 here, and then the back rectangle with a base and height of 16 and 10. Okay, moving on. One thing that's important to note here is that in addition to labeling with the numbers, I need to put the dimensions that apply. So let me go ahead and put here B equals H equals. Here would be B equals H equals. B stands for for base, and H stands for height. Okay. In the final step for finding the surface area for this problem, or for this triangular prism, I'm going to substitute the formulas for the figure. So the appropriate, and I'll put this in here, substitute the area formulas for the figures. I'm going to substitute the measurements in next and then solve. Give myself some space here. I might run out of room. Okay. So I'm going to have 2 times the area of a triangle plus the area of the first rectangle plus the area of the second one, and then the area of the last one. Okay, now let's go ahead and reference the reference sheet for those formulas. For the 2 triangles, I see that my area formula is 1/2 of base times height. So I'm going to go ahead and put my 1/2 base times height. Okay, for my rectangles, they're all rectangles even though they have different dimensions, also known as a parallelogram because a rectangle is a specialized parallelogram. Area is equal to base times height. So I'm going to go ahead and put that in for each rectangle. Okay. Okay, now I'm going to go ahead and complete by substituting in the measurements for the actual figures and then solving. So this is going to be 2, and let me put SA here because I'm finding surface area and it's important to note what you're solving for. Okay, so 1/2 of, for the triangles, the base is 12 and the height is 16. For the first rectangle, the base is 10, the height is 20. For the second rectangle, it's going to be base 10, following the formula, times the height of this rectangle, 12. And for the final rectangle in this case, we're going to have the base 10 times 16 for the height. Okay, working this all out. Using my calculator, as you can see, I've already begun calculating. From this point, from the point that you actually substitute in the measurements, you're basically doing the order of operations. So here I'm multiplying all the way through, and I got 192, and then 10 times 20, and so forth. Now we're going to go ahead and find, this is the area of 2 triangles. This is the area of this rectangle, the area of this rectangle, and they correspond accordingly. So at this point, we're going to now, according to the definition, find the surface area by adding up all of the areas of the different faces that we found. So let's go ahead and do that now. I'm verifying. I have 192 plus 200 plus 120 plus 160, and when I hit enter, I get 672. Okay, am I done? That's an excellent question. When I look back at the problem, I see that it wants the surface area in square inches, so I need to go ahead and add my units. And now I've completed my problem. So the surface area of this rectangular prism is 672 inches squared, which basically means that the areas of all of the faces of this rectangular prism that we started with, the area of each one of these individual faces added up gives you 672. Take care. Okay, going back to the problem for part B, we see that we need to find the volume in cubic inches. Using the same figure, I'm going to go ahead and borrow that figure from the first part of this problem. Using the same figure, I need to find the appropriate formula on the reference sheet. Now this is tricky because when I look at the reference sheet, I note that there's no rectangular prism for the volume formulas, but there's something that I want you to note from this point forward. Every prism's volume is the area of the base times its height. So here the formula is V equals big B, which means the area of the base, times the height of the entire figure. If you take a look at your reference sheet, you'll see that that is the volume formula for the rectangular prism. Okay, so let's go ahead and move on. So now we have to determine what these different components are. Okay, this requires us to go over the definition of the area of the base for a triangular prism, or any type of prism for that matter. For every prism, the base is going to be the two congruent faces. A prism can actually be turned to sit on top of those bases, or it could be laying down. It is your job to determine, based upon the two figures that are completely congruent and parallel, whether or not that's the base. So finding the area of this base, the base of this triangular prism, we have to take a look at it and say which two are the same. They are the triangles. So that means I have to find the area of a triangle, right triangle in this case. So going ahead and taking care of that. Labeling the figure, the base of that triangle is 12 centimeters. And the height was 16 centimeters. This 20 centimeters is great information for another problem, but extraneous for this problem. What that means is we don't need it because we know that the area formula for a triangle is, according to the reference sheet, 1/2 base times height. So let's go ahead and get that done. I'm going to go ahead and put a little triangle down here so we know what we're finding. 1/2 base times height. Okay, so area of this little triangle equals 1/2 of the base in this case is 12 and times height is 16. When we do the calculations, we find that the area of this triangular base is equal to 12 times 16. And then I'm going to, you have an option. You can divide by 2 because you're taking half of it, or you can multiply by 0.5 or 1/2. I'm going to go ahead and divide it by 2. In which case I end up with 96. 96 centimeters squared because it's area. Okay, now we're going to go ahead and find the height. Remember, we're filling in this formula, but we have to find the different components. So for the height, taking a look at the figure again. The height is a tricky concept in a prism because we always want the height to be perpendicular to the bottom of our page, but the height for a rectangular prism is going to be the segment that connects the bases. So since we determined that these two right triangles are the bases, we will be looking at this line right here because it connects the bases, okay? And that would make the height 10. No calculations necessary for that one. Okay, now we're going to go ahead and substitute the measurements and solve. So writing out the formula, I have V equal to, volume equal to, area of the base, that's what big B means, times the height. And that's what it means consistently throughout your reference sheet. Okay, so volume is going to be equal to, what was the volume, the area of the base? 96 centimeters squared multiplied by the height, which we found to be 10. And we end up with volume being 960 centimeters cubed. Note here that the centimeters were squared, and here they were to the first power because it just described a length, okay, a length of 10. So when you multiply them together, you get the 2 plus the 1 because the bases are the same, and that's why you have the cube. Take care.